lesson is what is a number system. So they can ask us what is a number system, and we should be able to answer that by saying that it is a method used to represent numbers. So what is a number system? It's a method used to represent numbers. Let's look at the examples. There are 4 main different number systems. What are those 4 main different number systems? First one is binary number system. Second one is decimal number system. Third one, octal number system. Fourth one, hexadecimal number system. So like that, there are 4 main number systems: binary number system, decimal number system, octal number system, and hexadecimal number system. Let us look at this table. Here, these are the 4 main different number systems: binary, decimal, octal, and hexadecimal. And this is their bases. What are bases? If you take this number system, there's this little number that is called as a base. That means when you take the symbols of the binary number system, there are only 2 symbols. So, addition to that, that is the base. So let us 10 is the decimal number system's base. So starting with 0, let us take this as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 symbols. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When we count them, the base is equal to these 10 numbers. So let us take 8 as the base, starting with 0, taking as 1, 2, 3, 4, 5, 6, 7, 8. It stops at 7 because you can't go beyond 8 or on 8. You have to stay below 8, the base. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers according to the base. So let us do this hexadecimal. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So as we discussed, this is the decimal number system. Like we talked, we can't use numbers of 2 digits. So we use the characters A, B, C, D, E, and F for the numbers with 2 digits. So we can say A, B, C, D, E, and F are the rest of this hexadecimal number system. Us humans are familiar with the number system called decimal number system. But computers are familiar with the binary number system. So let us take a look at the binary number system. Like I told you, 0 and 1 are the digits of the binary number system. When you take these two words, you can form the word bits. Now they are asking, what are bits? Bits are the binary, like we talked here, symbols. Easily you can familiarize with this. 0 and 1 are symbols. The binary symbols 0 and 1. The binary symbols 0 and 1 are called bits. So what are bits? The binary symbols 0 and 1 are called bits. We usually use the number 0 to represent that the computer or a device is turned off. And then we use 1 to represent a digital device or the computer is on. So 0 is for off while 1 is for on. So what are these digits belong to? The binary number system, or they are bits. Like we learned in grade 6 and 7, we know the steps of a computer: input, process and out. Again, getting some information in grade 8 about these 3 steps. What is information? Feeding data as text, images and sound. What is process? Process is processing. We're going to start with the same word. Processing data that's been sent as text, images and sound into binary form. Like I told you, humans are familiar with decimal number system while computers are familiar with the binary number system. So what is output? We can't understand binary number system, but the computer can. So the computer gives us the data it converted to binary number system as the decimal number system back to us. So we can say conversion of data in binary form back to, you have to mention the word back to, and conversion. Conversion of data in binary form back to text, images and sounds. So what is input? Feeding data as texts, images and sounds. What is process? I told you to start with the same word. Process is processing data into binary form. What is output? Since we can't understand binary number system, they give their information as decimal number system. So conversion of data in binary form back to text, images and sounds. So like I told you, a bit is 0 or 1. What is a nibble or what is a byte? let us go for a search. Since bit is these two symbols, let us take a binary number 1 0 1 1 0 0 1 1. There has to be 8 digits. So 4 of them is called a nibble. 4 of these is called as a nibble. 8 of these are called as a byte. So what is a nibble? 4 bits is called as a nibble. What is a byte then? 8 bits. So you can say a nibble is 4 bits or half a byte, because a byte consists of 8 bits, and when you divide it by 2 you get 4. So a nibble is 4 bits or half a byte, and a byte is called as 8 bits. So we know what's a nibble. A nibble is 4 bits. What's a byte? A byte is 8 bits. Then there comes the kilobytes, consisting of these, and megabytes, consisting of this, gigabytes, consisting of the megabytes, and the terabytes, the last byte. So you have seen these in your mobile phones as KB, MB, GB and TB. You might not have seen TB in your mobile phones, but they're in computers. So, like when you take grams, 1 gram equals 2000 milligrams, while 1 kg equals 2000 grams. This is the metric conversion. But in ICT, we take 1024. So we can say a kilobyte is 1024 bytes. Same repetition over and over. So like I told you, in ICT we use 1024 while we use 1000 in mathematics. So 1024 KB are present in megabytes. So 1024 MB is present in 1 gigabyte. 1024 GB is present in terabytes. So our next topic is conversions. Under this topic, we learn how to convert a binary number into decimal number and the decimal number into binary number. So this is all about mathematics. So I hope your class teacher have taught you this. So the first topic of conversions, decimal into binary. Let's take a smaller decimal number, 18. You have to continuously divide it by 2 because in binary number system there are only 2 digits. To remember that, add these two numbers, then you get 2. 1 is 1 symbol, 0 is 1 symbol. So 1 plus 1 equals 2. So continuously divide 18 by 2 and mark the quotients or the remainders. 18 divided by 2 equals 9. No remainders. 9 divided by 2 is 4. 1 remainder because inside 9 there are 4 2's. 4 into 2 equals 8 and remainder is 1. 4 divided by 2 equals 2. Remainder 0. 2 divided by 2 is 1. Remainder 0. And again you have to divide 1 by 2 equals 0 until you get this. Until you get the last digit as 0, you have to divide it continuously by 2. Remainder 1. So, you have to go upwards because every binary number starts with 1. 1, 0, 0, 1, 0. So, when 18 is converted into binary numbers, it's 1, 0, 0, 1, 0. You have to put the base as 2 like I told you earlier about bits. Let us get another number like 33 divided by 2 inside 3 1 13 6 remainder 1 divide by 2 8 remainder 0 divide by 2 4 remainder 0 divide by 2 remainder 2 remainder 0 divide by 2 1 remainder 0 again you have to divide 1 by 2 and the remainder 0. So that's it and 1. So go upwards from here onwards. You get the answer 1 0 0 0 1. Put the base as the answer. Count the zeros very well, okay? So we divided 18 by 2 continuously and got the answer as 1 0 0 1 0 2. And we divided 33 continuously by 2 and got the answer as 1 0 0 0 0 1. So next we're going for the conversation of binary into decimal. In order for you to convert binary numbers into decimal, you have to know the power of 2. 2 to the power 0 is always 1. Even if it's 10 to the power 0, 8 to the power 0, 9 to the power 0, 1 to the power 0, it's always 1. The answer is always 1. So 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, 2 to the power 5 is 32, 2 to the power 6 is 64, 2 to the power 7 is 128, 2 to the power 8 is 256, 2 to the power 9 is 512, and 2 to the power 10 is 1024. Creates byte. Just like that, you only have to know until 2 to the power 10. So, let us get a binary number. What about 1 0 1 1 1? That's a binary number. So, first you have to spread the number like this. So, I have spread the number. Then, like I told you, you have to write down the powers of 2 beneath them. Like this, 2 to the power 3, 2 to the power 4. Starting from 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. You have to add these. In multiplied by the number above the power. So if you see a 0, you just have to cut it down and get the others as 1, 2, 4, 8. You're not going to get 8 because you have cut down the value 0. Then you move on to 16. So what is 2 plus 3? 4. 4 plus 3 equals 7. And we get the answer. So if you want to do rough work, 7 plus 6 equals 13 and 23. You have to put the base as 10 because it's a decimal number system. So I hope you understand this lesson. If you understood this correctly, you should be able to do the activities in the workbook. And that's all for today from the Comma Key. Thank you.